Hello, and welcome to my tutorial series on how to make a 2D platform in Unity. In this video, we're going to learn how to move our character in the same way that Mario does in this video game. Let's get started. So in the last few videos, we created our little character Fabio here. We gave him a box collider, this little box right here for him to come into contact with things like the ground here. We gave him physics so that he can interact with the environment around him, so he can do things like fall and have mass, and we gave him ground to walk on. But now what we need is to be able to give him the ability to move on his ground. So to do that, we're going to have to code this, and to code this we're going to be using a C# script. So probably many of you who are watching this are new to coding, so we're going to take this step by step. So we're going to go over here into our assets folder. And we're going to go here into our scripts folder. And this is where our code's going to go. So we're going to right click, go up to create, and then go over to C# script. And we'll simply title this script Fabio. And then we're going to hit enter. And we're going to double click on this. And we're going to open up Visual Studio. So Unity uses a coding language called C#, and C# is an object-oriented language that was invented by Microsoft. And usually when we talk about object orientation, we are talking about these things called objects which will share a commonality with each other. And that, like many other things about to talk about, I'm just going to have to just give you a brief definition of things and just sort of move on so as not to make this too complex for beginners. But just know that here we have these three using things right here, and these are called namespaces. And as you can see, it says using system.collections, using system.collections.generic, and using Unity Engine. And namespaces contain code in them, for lack of a better way of describing them, and for us to use in our code. And these two right here, these are part of what is called .NET. And .NET was what C# was created for. It's for developing software and applications for Microsoft. And using Unity Engine, obviously, is a version of C# for Unity. And everything after it is part of this using Unity Engine. All this right here, this public class, Fabio mono behavior, start and update. These are all only there, or they can only be there if we have this using Unity Engine. So if I were to take this away, if I highlight it and just cut it out for a second, and then hit save and go back into Unity, it's going to give an error. It's going to say the type or namespace mono behavior could not be found. And it can't be found because I don't have my collection of code here that I'm using, which would be the using Unity Engine. I need that to be able to use mono behavior. And mono behavior is what's called a class. And a class really is just short for classification. So there's a public classification. It's called Fabio because that's what we named it. And it's very important that when you name a public class that you're using the name of your script up here. Otherwise, you'll get an error for that also. And you know, this public class is part of mono behavior. It's what all our code is derived from. It inherits from it. So back up here, we have these namespaces. We need to use them, as it says using, in order to put in our code. But furthermore, our code derives from this class also. And actually, you're going to see the word public here. And there are two terms we'll see going forward. One will be public, one will be private. Public means that any other script can use it. If we put private here, nothing else can use this, but that's not what we want at all. So we have this public class called Fabio. It's mono behavior, and everything inside of it derives from it. So the first thing we're going to see that derives from it is this void start parentheses and these curly brackets right here. And it tells us right above it that start is called before the first frame update. Now these two little these two little forward slashes, if you put this in front of something, it's called a comment, and it's basically taking notes in your code. This line right here has no effect on our code whatsoever. I can even go make another one and put hello everybody, and it has no effect on the code whatsoever. And there's other ways to use comments which we'll use later on. So a little note here says start is called before the first frame update. So before the first frame is played, there can be a bunch of code that gets implemented, and this is all put into this start function right here. Now after that, you'll see that there is another note here. It says update is called once per frame. So just as it suggests, the game is going to run in frames. So for every time a frame plays, there is going to be a bunch of code that we're going to put here that's going to run. So there's going to be a bunch of code that's going to happen at the start, and then after that the frames are going to start playing, and every time a frame plays, another bunch of code will be implemented. And these two things right here, these are called functions. When you see something, it doesn't always say the word void, but a function is a set of code, and these are standard functions that are used here in our Unity engine. So usually they'll say void, which means they don't return anything. So that's a little more complicated, and the idea of returning something in your function will be set forth for another day. But if you want to jump ahead on it, there is a video I have in my C# playlist that covers functions. If you just want to go to that right now and learn a little bit more about functions, and some other C# functions, or I'm sorry, C# topics are in that. So we're going to go ahead and start coding our movement. Up here, right under where it says public class Fabio mono behavior, and just inside this curly bracket, what we're going to type is we're going to type the word private, and then we're going to type the word rigid body 2D, just like that. And then it's going to be a space with an F, an underscore. Then we're going to type rigid body 2D, and then we're going to put a semicolon. So earlier I discussed the word public, meaning that it can be used by any script or anywhere. And now here I have the word private. Just going to put a space bar here to see it a little easier. Private, which means that whatever I'm typing here, whatever this code is, can only use by this script. So what this code is that I'm saying there's a rigid body 2D, and that rigid body 2D is right here. Let's just let this load a second. So it's our Fabio character. He has a rigid body 2D on him, a component. So I'm telling the code, there's a component, there's a rigid body 2D component, and I'm naming it F underscore rigid body 2D. This is just a name I chose. You could write any name you want here. I just put this F for Fabio, and just to annotate for the purposes of this tutorial that this is his rigid body 2D. So I'm declaring that there is this component, and I only want to use it for this script. That's why it's private. So the next thing I want to type is, I'm going to put the word private again, and I'm going to put the word float, and I'm going to type base direction with a capital X, and then I'm going to put a semicolon at the end of that, just like I did here. So whenever we end a line of code, we put a semicolon at the end. That tells C#, hey, this line is ended right here for this code. So here I put a private float. All right, so it's only going to be used for this script, and I called it face direction X, and you'll see later on why I called it this. This is to be able to, so when Fabio moves, he's going to face left and right. So it's going to be important to have something that annotates which way he's facing. I don't think we're really going to quite use it in that manner quite yet, but we want to set it up now. So that's why it's called face direction X, and X just meaning the X-axis. So a float is basically a number with a decimal. There's a couple different types of variables, that's what a float is, that we can make. The float is 1, and the other one is called int, and let's just name this int num just for now. So a float is a number with a decimal. If I want to, this number is going to have a decimal to it, and you'll see further what this float is going to be about. and an int is a whole number. And these are two of the type of variables that you can use in C#. And like here before, these are just the names I called them. I just called that num just for now. It was just an example. We're not using any ints here. But anyway, there's this private number. It's going to have a decimal, and I called it face direction x. The next one I'm going to put another float, but I'm going to call this one public. I'm going to say public float move direction x, and I'm going to create another public float. Actually, I'm just going to leave that one out. I don't need that one for now. So I'm creating another float. It's going to be public. And so I'm going to hit save here, and I'm going to show you something, the difference between the public and the private. So one of the differences, actually, if we go into Unity. So here in Unity, I'm going to go up to the Fabio game object here, and I'm going to attach our script to the game object. There's a couple ways you can do this. You can hit add component, and I could write or type Fabio, and it's going to appear right there, and I can click on it like so, and then the Fabio script will be there. Or I'll remove it, or I can just take it and I can click on it, left click it, and then drag it over here to my component. So those are the two ways to attach a script to your game object. And the game object will not work if you don't attach the script to it. So here I have my Fabio script, and here you can see it says move direction x0. And the reason why it says it there is because I made this public right here. And that's why this one doesn't appear here, because it's private. So when I make a public variable, I can go ahead and put it right here, and I can change it. So, if I don't like the speed by which my character moves, I can always change it. I can make it lower, smaller, without having to go back into the code and change it. So that's a good, or that's one of the good things about having a public float. So now up here, what we've done is declared our components and variables. We said, hey, we have these floats, we have this rigid body, and this is what we're going to call them. But we've only declared them up here. We haven't used them for anything yet, and that's what we have to do. But it's very important that you declare these things before they're using. This is a very important function of C# coding and most coding, where you want to say what it is you're using and then use it. Otherwise, you'll get an error. So over here in the start function, we're going to use our rigid body 2D component. We're going to say f underscore, and then right there it allows me to just hit enter to fill it in. And then, actually, I got to put F2. Oh, wait, the 2D's there. Never mind. So after that, I'm going to put equals. I'm going to say that this thing is going to equal, and then what it's going to equal is to equal get component, and then I'm going to put a bracket. Actually, I'm going to put two brackets, and in between those brackets, I'm going to put rigid body 2D, and at the end of the brackets, I'm going to put a parentheses, and at the end of that, I'm going to put a semicolon. So what I said was, hey, I declared this rigid body 2D, but it's going to be a particular component. I declared it up here, but over here, the rigid body 2D is going to be used to get a component. And this is what we're going to call it for our use in other places. So it's going to actually, at the start, when we hit the start button, it's going to go get this component. This is what it's referring to. And it's going to grab that component, and it's going to give it that name in the memory. So now we have this instance where we hit start, we get this rigid body component, we give it a name. And by the way, we give names to things like this not only to grab them, but it's just easier to use. So now instead of in different places, instead of typing get component rigid body 2D, I give it this much shorter name, and I can use it elsewhere in the code, which is what I'm going to do. So now after we do that, we want to move our character, and remember our character moves once per frame in the update function. So what we're going to do is we're going to type face direction x, and that's going to equal input dot get axis raw, and next to that, we're in parentheses, we're going to put a quotation mark, and we're going to type the word horizontal. Oops, that's wrong. Put that at the end. So what we're saying over here is that once per frame, what we want to do is we want to have a float. We want to have this number, and this number is going to equal to input.getAccessRaw horizontal. So input is just telling the code that, hey, we're going to input something. This is our control of the character. In this case, it's going to be a right arrow to move right, a left arrow to move left, and also our DNA keys can do the same thing. And so getAccessRaw means that we are interested in an access, obviously left to right. Now, the raw part references at the idea that we can actually have a get access. And get access by itself kind of has this smoothing component. So when you hit the button, it smooths it out a little bit. But when you type raw, it means it just gets it right away. And that's what we want for a game like this because it's a precision platformer. And now horizontal makes a reference to the input manager. And we're going to find out what that is right now. So we're going to go over here and we're going to go up to edit and we're going to scroll down to project settings. And inside it, you'll see we have this input manager. You can just click on that and you'll see we have all these axes right here. Yours might look like that. When you click down on that arrow, it will show you all these things: horizontal, vertical, fire, jump. And here's ours. Here's the one we want horizontal. So it's called horizontal. And we can use the left arrow, the right arrow, or the A key or the D key. And this is also other things like gravity and stuff like that, but we're not into that right now. So what it basically says is that if we hit the left arrow or we hit the A key, our number is negative. And then that's where making face direction X a float comes in, because we're saying, hey, if we hit the left arrow, this number we created, this float, is negative. And if we hit the right arrow or the D key, then our number is positive. So that's where that comes in, and we'll be using other components of the input manager. We're going to come back to this another time. So going back to our script, we now have our number if we push the arrow keys or the A and D key, but now we have to do something with that. So we want to tell the computer, if we push the D key, we move right. And if we put the push the D key or the right arrow, we move right. And if we push the A key or the left arrow, move left. And we do that through something called an if statement, which makes sense because we want to say if this, then that. And that's what an if statement allows us to do. So to set it up, we type the word if and we make a parentheses, and then we're going to go ahead and make two curly brackets. So in the parentheses is where we put our parameters. So this is actually called the argument. So in here, we're going to say if this. So in this case, this is that we're going to say if face direction X is greater than 0. So when we push the D key or the right arrow, it's going to give us a positive number. It's going to be greater than 0. And if this happens, we want to say, oops, we don't want that one. We want to say our F rigid body 2D right here. And then we want to say if F rigid body 2D dot velocity. All right, so we have our rigid body 2D. We defined it as this. Dot velocity means where we want to access its velocity component, which is its speed. And its speed is going to equal to a new vector 2. So each frame that happens, because everything we're doing is once per frame. Every time there's a frame and we're holding down this button, this input button, it's giving us a new vector every time it happens. And that vector is going to have two components. It's going to have an X component and it's going to have a Y component. And our X component is just simply our move direction X, and our Y component is going to be our F rigid body 2D dot velocity dot Y, meaning that whatever speed in the Y direction, which is up and down, which we haven't quite gotten to yet because we haven't done jump yet, but whatever this is just going to remain the same here. We could put 0 here, but that could be quite restricting. So we basically want to say, when we push the button, regardless of what his speed in the Y direction is, we want to be moving this speed. So with that in mind, we're going to put in a semicolon at the end. And now let's just check this out. We'll do the left-hand side right after this. So let's let this compile. And over here in our move direction, yours might say 0. I think I put 1 in earlier. So we're just going to make this 1. It'll probably just keep slow so we can use it. So now when I hit play, I can move. I'm just touching it right now. I can move to the right, and it's slow because I put 1 down here, and that's the way I wanted it. I can move to the right when I push D or the right arrow key. That's my velocity. However, nothing happens when I push the left key or the A key because I haven't coded that yet, and we're going to do that right now. So right here, we put this if statement, and now sometimes if you want to add to an if statement, you can put something called an else or an else if. And we'll be using these a little more in the future, and I'll be going over them more in the future. But basically we're saying, all right, if base direction.x is positive, then this, and obviously if base direction.x is less than 0, or basically if we're hitting the left arrow or A key, then obviously we want them to go the opposite direction. And to do that, we simply just got to change one thing from this code. We're just going to simply copy this, and then we're going to paste it. And then the only thing we have to change is this right here. We're going to put a negative sign right there in front of move direction X, because now this is the positive direction. When we do this, we want him to be in a positive direction. So, and this one we want to be in a negative direction. So positive is right, negative is left. Let's go back in. Let's let it all compile. Let's go into our game. And now let's hit play. And now this is still going to be a little slow because it's on 1. So moving the right key goes right. Moving the left key goes left. Let's just speed him up a little bit. Let's make him 3. So now you can see that he moves faster. And that's all changed right here. And that's why we made this a public variable. You can make it as fast as you want. So now he's got some movement. However, if I let go, you can see that he has a lot of sliding here. So we've got him moving, but we have a little bit more work to do to give him those precision movements, and we'll be doing that in the next video. So that's it for today. As always, thank you for watching. Like this video, subscribe to my channel, follow me on Facebook and Twitter, and support me on Patreon. And a big special thanks to all my Patreon supporters. See you next time.